Today we'll talk about what's called series. So we're still in section 9.1. And we'll talk about what a series is. So remember what we've been doing. A sequence is just a list of numbers. And they're generally separated by commas. What a series is a little bit different. A series is a sum of the terms in a sequence. So in order to talk about series, we have to talk about what's called sum or sigma notation. Generally, it looks like an E. You might see this if you ever use Microsoft Excel. And the bottom section usually looks something like this, like I is equal to 1, and the top is N, and then you're given some kind of like argument right here. So this section in the bottom, this tells you what you're starting at. And this number right here tells you what number you're finishing at. Right? So for example, the way that we would write this sum is we would start at 1. So I is 1, and we would add, go to the next one, 2. Go to the next one, 3. Go to the next one, keep going up by 1 until you get to n, whatever n happens to be, and then you would add those together. All right, so let me show you some examples with this. The directions are going to be evaluate the following. So let's say we had the sum from I is equal to 1 to 5 of 3i. Now what this means is we do 3 times 1 plus, you go increase this up by 1, 3 times 2 plus 3 times 3. Keep going up by 1 until we hit the n number, which was 5. So really, I mean, we could just factor out a 3 from all of these. No matter how you want to do it, I mean, you could just type it into your calculator, but this would be 45. All right, a couple more. What about the sum from k is equal to 3 to 6 of 1 plus k squared? So you would say 1 plus 3 squared, starting at 3, plus 1 plus 4 squared, plus 1 plus 5 squared, plus 1 plus 6 squared. We're stopping at 6 because that's the top number. And if you were to figure these out, this would just come out to 90. You could just type that into your calculator. And then the third one says, how about the sum from n is equal to 0 to 8 of 1 over n factorial. So we're going to do 1 over 0 factorial plus 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, 1 over 5 factorial, 1 over 6 factorial, 1 over 7 factorial, and 1 over 8 factorial. So you have a factorial button on your calculator, and if you were going to do this, this is 1 plus 1 plus 1/2 plus 1/6 plus so on. That number would be about 2.718. Put an extra decimal there. That's actually the number E. If you remember, we talked about E when we were talking about natural logs, right? So what E actually is this is the definition of E. E is the sum from n equals 0 to infinity of 1 over n exclamation point. So you could look back in our notes on natural logs, but that's how you would figure that out. We have some properties of sums. One of the properties says that if you're taking the sum from 1 to n of a constant times a to the a sub I, you could just take that constant out. So figure out what that term is, and then once you get all those sums, you could just multiply by c. It's a little faster. Another property is the sum from I is equal to 1 to n of a sub I plus b sub I. We could actually break up the summation to be the sum of the first plus the sum of the second. And the last property would be the sum from 1 to n of a difference is equal to, yep, you guessed it, you could separate these. Now, anytime you're going to n, that's called an infinite series. We talked about this a little with sequences. An infinite series is one where there's no end. It's just infinite. Start at 1 and you go to infinity. A finite series is one where there is an end. All right. So let's do a couple examples. What I would like you to do is find the third partial, and partial is just another word for finite, sum, and the infinite sum of from 1 to infinity of 3 over 10 to the I power. So first let's find the partial sum. So that just means for the first 3 terms. Then we'll do the infinite sum. All right. So for the partial finite sum, we're only going out to 3. So what this means is we're doing 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third. And that would be 3 divided by 10 is 0.3, plus 0.03, plus 0.003 would give us 0.333. You You can kind of see what's happening here, right? So then what if it was the sum from 1 to infinity of 3 over 10 to the I power? Well, it'd be 3/10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000, and you would have 0.3 plus 0.03 plus 0.003 plus 0.0003, which would really just be 1/3 if we just kept this pattern going forever. All right, so for homework, what I would like you to do is on page 626 to 627, I'd like you to please do numbers 81 to 87 odd and numbers 105 to 111 odd. All right, good luck. Have a nice day.